Thank you, Eric. Wow, that really sounds, it sounds like there's a lot to Industry 4.0. And if you're a small business in Michigan, you know, and you do manufacturing or you do design, you're sitting here trying to figure out where do you even start? You know, what a potentially Herculean undertaking. Just a little bit about our company. We're Calumet Electronics. We make printed circuit boards and soon IC substrates for microelectronics. We're located in the northernmost part of the Upper Peninsula, so we're pretty far from supply chain. And we're doing interesting things and interesting technologies that we believe as a Michigan company, we're going to outpace things that are going on in California and in even Silicon Valley. You know, we are a technology industry. I'm an electrical engineer. I'm a computer programmer. I'm a geek. I love robots, you know, and I read sci-fi books. So I can imagine this this industry 4.0 that's coming. And yet I sit as an operations manager, a COO of a small manufacturing business, and I'm like, how do we get there, right? Let's talk about automation for 1 second. Let's say, you know, the fourth industrial revolution and you know, factory 4.0 and smart factories, it's all about automation, right? You know, and Asia is doing that really well. You know, they build 500,000 iPhones a day, and you know, it's all about the automation. But what are our customers domestically or in the United States asking for? You know, they're not necessarily asking us for you know, this huge amount of volume, which adapts very, very nicely to automation. You know, we're being asked to manufacture a low quantity of a very complex design, which can pivot during the manufacturing process. And if we know anything about automation and robots and scripting and programming, is once it's programmed, it doesn't change really until somebody comes along and makes those changes. So are our customers asking us for advanced automation, or are they asking us for advanced products, which you may or may not use advanced automation to do? So we know that most of this manufacturing that we've lost to Asia isn't coming back. They're too far ahead. So how do we, as manufacturers, small manufacturers in the United States, actually become competitive? How does the United States become self-reliant? How do we, right now, it's something on the order of like 90% of you know, advanced electronics, they're coming out of Asia, right? And then that kind of is a security risk to our, you know, our country. And that's part of the things that we're working to figure out how to solve. So, you know, the question really becomes, are we really trying to build a smart factory at Calumet Electronics, or are we really just trying to build like a factory of the future? And there's a lot of different ways that that can actually be defined. One of the things that we're interested in is, you know, in Michigan, if we can make Ford F-150s at a great pace, what does it look like to make, you know, the low orbit satellites, you know, that are going to be used for, you know, broadband communication and those types of things. So we, as a company in Michigan, are struggling, you know, with this idea of how do we take, you don't get to start from scratch. You know, we're a going concern. We ship 4 million circuit boards a year out of this facility. We can't stop producing for a day. So what are the steps? You know, how do we become more competitive? How do we leverage automation, right? Part of where we think we would start, or that we have started, is with simply putting barcodes on all of our products and allowing the machinery that normally you have, you know, a human that goes in and hopefully types in the right part number or the right recipe into the machine. Instead, there's some sort of a scanner on this machine that the part comes in and it can see that, and then it can automatically load up the right program or automatically do the right things. Something else that is really capturing our interest, we are engaged with some DoD primes, with IPC, which is our main trade organization, and other businesses to try to take initiatives to take this kind of manual industry that making circuit boards is and make advancements. Digital transformation, augmented reality, where they're having a problem with a piece of electronics in another country, and everybody in the supply chain can, you know, put on the headset and everybody's seeing the same thing. And we can figure out that the tier 2 provider put a screw here, which is interfering with a circuit that the tier 4 provider put here, and we can all be on the same conversation. Those are the kinds of concepts that are being actively explored. But a little closer to home is this idea that we have manufacturing equipment. We have PLCs that are running $27 million worth of computer hardware that goes all the way 20 years old to just brand new. Is that we can begin to put these sensor systems that we actually put on top of the PLCs so that they can see everything the PLC is doing. They can read all the sensor data, and they can take that information and build up basically large data sets of information, which can then be used to make decisions or detect problems. So I think I'll kind of finish up. I don't want to go too long here, but with one example is we have a wet process line that does something to make a circuit board. It's got 10 steps in it, and each one of those steps we do statistical process control on. We need to monitor 3 to 8 parameters in each one of these chemical baths, and we need to understand a lot about it. We can have every single module in this unit give all green lights, yet somehow a product that comes out the back end is non-conforming. And the question is why is that? Well, maybe the third process is in spec, but it's actually running, you know, at a tolerance that it's running at the bottom end of the spec. And this process down here is running at the top end of the spec. So even though both processes are in spec, this misalignment across the entire machine is creating you know, a kind of a boundary condition that can result in a nonconformance. So what might we do? Well, we might use an industrial standard like CFX, Connected Factory Exchange, to pull information from that system and then feed it to an AI signature just like facial recognition, except you're not recognizing a face. What you're recognizing is the statistical process of these various processes. And then you do signature recognition. You basically say, you know, when we're making good product, because we've been training the system, good product, when something comes out that could be a bad product, the system can recognize that. So then it can alert us. It can say, hey, guys, across this particular machine, which is a legacy machine that's been overlaid with a data acquisition system for statistical process control, we can take that data, do AI analysis, and it's going to tell us, hey, you're probably making bad product right now. You just can't see it using the traditional methods. So that's an example, I feel, of something that is obtainable or doable, you know, for a manual factory to start taking those kinds of steps forward. And I guess I'll stop there.